All right, let's jump right into this explainer and look at a pretty mind-bending transformation. We're going to trace exactly how a sterile, boiling ball of lava, just floating out there in quiet darkness, somehow transformed into this beautiful planet teeming with life. It is arguably the greatest story ever told because, well, it's the exact story of how you and I aren't literally able to be here today.
So you might be wondering, how exactly does a ball of boiling lava pull that off? How does it become a living world? The answer is definitely not some peaceful, gradual evolution. Actually, our existence relies on a series of incredibly violent, fortunate accidents that had to happen in a very, very specific order. We are, essentially, the grand prize winners of a chaotic, cosmic lottery. And it took 4.6 billion years to execute this perfect cosmic recipe. Back then, there were no planets, no sun, just darkness and this massive cloud of dust and gas, mostly hydrogen and helium. That cloud just drifted peacefully for millions of years until something extraordinary happened. A dying star exploded right nearby.
That brings us to phase one, the birth of the solar system, which was truly a supernova's gift. The shock waves from that massive explosion collapsed our quiet little dust cloud into a flat, fast-spinning disk. Extreme heat and pressure built right at the center, eventually igniting nuclear fusion and birthing our sun. And this newborn star was hungry. It greedily swallowed up 99.8% of all the matter in that entire disk. To put that into perspective, that left a tiny, tiny fraction, just 0.2%, for absolutely everything else. Every planet, every moon, every asteroid. But nature is incredibly efficient, and that tiny 0.2% of dust did not go to waste. Over tens of millions of years, those tiny particles started bumping into each other and sticking together. This is a process called accretion. At first, they're just held together by static or chemical bonds, but as they grew into rocks and eventually into larger bodies, gravity took over, pulling them into rocky protoplanets.
Which leads us directly into Chapter 2, Earth's hellish beginnings, the lava ball stage.
Let's look at how this builds into the planet we call home. Though, to be honest, home is a strong word for it back then. It was about 10% smaller than it is today, and completely unrecognizable. As you can see on this timeline, for the first few 100 million years of its life, our world was not a peaceful globe. It was undergoing constant, unimaginably violent collisions. We call this the Hadean Aeon, named after Hades, the Greek god of the underworld, and it was literally hell on Earth. Objects up to 200 kilometers wide were constantly smashing into the surface. The kinetic energy from those impacts completely melted the rocks, turning the entire planet into a 12,000-degree molten ball covered in endless seas of lava. But out of that absolute hellscape came Stage 3, the giant moon impact. And really, this was the best disaster to ever happen to us. It all involves a Mars-sized planet named Theia. This single event totally changed the trajectory of our planet's history. For a really long time, scientists debated how our moon actually got here. It's a huge puzzle. People threw around ideas like, oh, maybe Earth just captured a passing moon, or they formed side by side. Actually, scratch that. It was the Apollo missions that brought back the real proof. Lunar soil samples showed oxygen isotopes practically identical to Earth's. That proved the giant impact hypothesis. This planet, Theia, slammed right into our young Earth at 9 kilometers per second. That is incredibly fast. This catastrophic hit vaporized our surface, but Theia's dense iron core sank and merged with ours. The debris blown into space formed our moon. And this is the absolutely crucial part. Without this collision, Earth wouldn't have its 23.5-degree tilt. That means no changing seasons, no oceanic tides to eventually coax life from the water onto land. It was a total game changer.
Okay, so we have a rocky planet and a moon, which brings us to phase 4, delivering water to Earth through an icy bombardment. Because right now, the surface is scorched. So how does a boiling lava world get the water for our oceans? Well, it took a cosmic game of billiards. Jupiter started moving inward toward the sun, but Saturn's gravity yanked it back, pushing Saturn outward. Saturn then shoved Uranus and Neptune further out, and Neptune was shoved straight into the icy Kuiper belt. This chain reaction sent a 300-million-year shower of ice-filled comets and asteroids flying straight into Earth. Just think about that for a second. Every drop of water you drink today, every ocean wave, was delivered from space by an icy asteroid over 4 billion years ago. These space rocks continuously pelted our molten planet, cooling it down and increasing our mass by up to 20%.
But having water doesn't really matter if it all just boils off into the vacuum of space, right? Earth desperately needed Phase 5, building an invisible shield powered by the core's engine. During the Archean Eon, the molten Earth sorted itself out. Imagine water seeping down through sand. Because of gravity, the heaviest elements, like iron and nickel, sank deep into the center. The lighter elements bubbled up to form the crust. This separation created a scorching 6,000-degree core right at the center of our planet. And this churning liquid iron outer core creates our magnetic field. It acts as a shield against deadly solar winds. To put it simply, without it, we'd be Mars. Mars used to have oceans too, but its core solidified. It lost its magnetic field, and the solar winds just stripped its atmosphere away, leaving it a barren wasteland.
That brings us to our final stage, Stage 6, the perfect recipe for life against all odds. Extreme volcanic activity released massive amounts of gases, and thanks to our new gravity in that magnetic shield, the gases stayed put. The water vapor condensed, rained down for millions of years, and filled our oceans. As our sources point out, we hit the ultimate jackpot. Everything that happened was exceptionally fantastic. The perfect distance from the sun, the exact right greenhouse effect, a protective shield, a moon for stability. It is so incredibly rare for these many things to happen correctly. So, what does this all mean for us? It leaves you wondering, if just one of these violent cosmic accidents didn't happen exactly as it did, would we be here? When you realize how fragile this rare, beautiful planet of ours is, and the impossible 4.6 billion year journey it took to get here, doesn't it feel like it's our absolute duty to protect it? Definitely something to think about. Thanks so much for joining me on this explainer, and I'll catch you on the next one.